Santona Tuli. I head up data at a startup, or a Series B startup called Upsolver. The company started in Tel Aviv, Israel, and now there is a US function, and that's where I come in. This is my puppy. Her name's Ridge. That's the entire thing is her name, but her call name is Ridge. And it's important for me to have her picture on my talks. Okay, so I'm going to talk about simplified. Is it this one or that one? Okay. I'm going to talk about simplified real-time data workflows. So Upsolver puts an emphasis on real-time streaming data. So we'll talk about that. First, a little bit more about me. So I started working with data as a particle physicist at CERN, where we would collide particles at really high energies that would produce a lot of other particles, and we would try to capture that data inside of a detector, and then try to answer questions about what happened after the Big Bang, et cetera. And so I started there with data. I was focused on data engineering, data quality, and also machine learning engineering, and I've always really enjoyed giving talks and meeting people, so that was also that's always been a part of my journey. Then I've worked at startups since. I worked at a startup called Directly, which is now part of Movate. There I was an ML engineer. I did deep learning, NLP, natural language processing. And I owned the ML service that we had for serving up the predictions. Sort of by trial and error, I did some like data ops, DevOps type work. So that was fun. And then I went to a company called Astronomer, which is a managed Airflow service. So I've been using Airflow directly, so I thought I might as well help build this tool. So I went to Astronomer, and that's when I started doing sort of work that is almost data science adjacent, while still having a data title, which is still what I do. This is what I mean by that. I started doing more user research, understanding developer stories, developer pain points for data practitioners like myself and some of you guys, and then incorporating that into what we were going to be building so that the tools that we built were actually useful to people. And that's still what I do. So focus specifically on data workflows, data orchestration, which is what Apache Airflow does. Also what Upsolver does, and whether you're using the pipelines for analytics purposes, ML purposes, whatever it may be, I sort of a layer deeper in that and sort of thinking about how the pipeline fits together. So that's me in a nutshell. So I thought I'd mention the tech world is quite small. So my partner used to work at Included Health before.
Yeah.
He's also an ML engineer. So the way that we think about it from the Upsolver perspective, this is also my opinion, is most of the data products, what we call data products, which is not a well-defined term, but I'm actually doing a podcast tomorrow on that, so if you're interested, follow me and listen to that podcast. But as when we serve data products, whether they're end user facing, or internal, like for the purposes of analytics, other folks at the company are going to use it. Increasingly, we're seeing a need for near real-time data products, like folks just want their results faster and want their information faster. Probably something to do with the scrolling that we do. And my definition of data products, near real-time data products, are gonna include data as a product. So where we productize the data, and that is our deliverable, as well as analytics as a product, where usually the deliverables are things like dashboards and reports, as well as ML products, which can look like the kind of data service that Included Health provides, right? Like it's a matching, and I mean I won't do justice, but basically you're matching provider to someone who's seeking care or something like that, or the recommender systems that live on Amazon.com, etc. So, and we focus on data freshness because basically out of date data makes for bad user experience. So If we have out-of-date data, when we have data as a product, then we end up making bad business decisions because the data is just not relevant. If our analytics are out of date, then we have a delayed understanding of how our business is performing. So analytics, the primary purpose of business analytics is to figure out how are we doing, how are our customers feeling about our product, what's missing, whether a customer is going to churn or increase their workload, et cetera, et cetera. So if I'm looking at data today from last week, that might not be good enough. I need to be looking at the most current data that I can. And then usually ML applications are the most end user facing of these. So out of date predictions in my recommender system. An example of this is when you looked at a backpack yesterday and now you're getting 5,000 backpacks being advertised to you, right? So again, bad data equals bad experience. So today, there are two ways in which we supply our near real-time data products, right? We have batch processes and we have stream processes. That's just how we do things, right? So more fundamentally, and folks who work in applications are much more familiar with this. Usually, like services talk to each other through various message buses, and that's kind of like it's real time. Data is passing as it's being generated, but we often collect the data from different message queues and collect them into batches, and then do something batch-wise on top of that. The challenges with batch processes for near real-time data products is they're only fresh up to an interval. So if I'm doing something every day, that's the best that I can promise as far as freshness. If the pipeline run fails, then the next time that the pipeline is going to run, there's going to be a gap in my data, and there are other ways in which the failure can be essentially compound. So you have to come in, manually fix it such that, and then do backfills so that you're caught up. And the backfills are manual. So what we tend to do to overcome this challenge is to speed up our batch intervals, right? So what we used to be doing once a week before, we're trying to do once a day now. Once a day is going to once an hour, et cetera. But you still have the fundamental issue of how often can you actually run batches, because sometimes the computation that you're doing, right, itself takes some time. And if you're collecting things into a batch and then running some processes on that, you have to account for that time. And then run failures is a problem that is not solved by just running more frequently. With Stream, there's a unique set of challenges also. So streams come at their own cadence. As I said, the data are generated, and then we receive them. So it's like the data control when they arrive, when they flow. And it's a always running process. So you sort of have to come in and try to stop a thing that is naturally wanting to flow if you want to fix issues. And stream transformation is kind of hard because you have to look at, you're trying to do operations on a single record of data at a time, but you often need context across other records as well, so it's called state, and you want to have that in memory as you do processing. So we try to do as much transformation as possible, but there are other challenges such as, well, what if the answer that I'm trying to get relies on two different streams of data? How do I combine two different streams? Or even, how do I combine a stream with a table that's sitting somewhere? It gets a little bit complicated. So the reason for that is that dependencies between things, which is the whole point of orchestration in the streaming context, are harder, just because things are moving. This is the obvious slide. When you have a service or a platform that's trying to combine stream processes and batch processes into one to serve up near real-time data products, well, things get even harder. And that's fundamentally because our underlying infrastructures are too different for batch processing and stream processing. Okay, so that's the summary. They're fundamentally different. We've tried a few things on both sides to unify them. Hasn't worked super great, And more use cases require have both a streaming and a batch component. So we need to try something new. So here's a solution of a unified pipeline authoring framework. So basically, this is sort of our batch world, right? We've got our Spark engine and other similar engines. We've got our databases. We do our modeling in dbt, et cetera. And that can be orchestrated in an orchestrator like Airflow. There's many more now, Prefect, Dagster, et cetera. And it's sort of a layer that's sitting on top of whatever frameworks you have, doing the actual work to string everything together. And things are scheduled. Things are going to happen either on the clock or after something has happened. So that too is a more recent sort of advancement, if you will, in the batch world, is like data set based triggering. Okay, and then there's the stream world. We've got the Flink, etc., Kafka, KSQLDB, and our streams are real time, and the dependencies are inferred, as I said. So when we move to the unified landscape, fundamentally what we want to do is we want our pipelines to be data aware. So that's one of the biggest pain points with batch orchestrators, is that by design, they're supposed to be, each process is supposed to be idempotent, and the processes aren't actually meant to know about what's happening inside them. They're just like little execution blocks. And we kind of want to flip that idea on its head and instead say, my pipeline is going to be data-driven. Data-driven is a loaded term now, but it's just putting data in the driver's seat. The data is going to decide when things get executed and what the relationships and dependencies are between things. So as going into building this product, right, this unified platform for authoring batch and stream pipelines, we wanted to figure out what are some specific requirements. We know what we want to do overall, but what are some specific requirements? So if I'm a data producer, again, this comes back to the infrastructure disparity in the infrastructure. So I want to keep using things that I'm familiar with, and I don't have to fundamentally shift my perspective. And then as a consumer, so let's say I am a business analyst or data engineer sitting in a domain-specific team, like customer success or customer support or site reliability. I am using data that the data team, let's say, or the ops team is providing, and I don't want to have to fundamentally change how I consume that data. So I still want to be able to look at my dashboards and look at my tables and so on and so forth. I'm comfortable in SQL. I want to be able to query my data myself. So approaching the solution, the reason we go stream first is because it's easier to supply real time with stream first. Data as a driver helps data triggered pipelines, data defined dependencies, and we can set up data contracts between each step. But this does mean, as I was alluding before, that we need a lot of information about the data that's flowing through, and we need to hold state in some sort of way, in some accessible way as the data are flowing, and have some sort of metadata store on top of that. So we went for a data lake architecture with materialized views that allow for joins that are essentially, you're joining two streams as snapshots of themselves. Which I'll go a little bit more into that in a second. But yeah, so this allows us to do staging of our data and then modeling, so transformations, all within the same platform. And the other decision was to stay in SQL, because it's kind of like the lingua franca of data. So this helps, again, with the consumers also consume from the same place that the data producers are producing their data. So this is basically the logical design. We have all data. So as soon as source data, as soon as data from a source is consumed, it appears as tables in my lake. Then I do transformations, I do aggregations. Each of those are accessible, queryable as tables in the lake, as well as historical data lives in the lake. And then from there, you pass on those aggregations or whatever you want you can go into data warehouse, data lakehouse, BI tool, and all applications, whatever you want. So how's this different really from like loading into a Snowflake, for example, right, into the data warehouse directly? This is a lot more efficient. The data are compacted, the file structure are Parquet files in an S3 bucket, and we just have a rich metadata store on top of that, such that you don't need to do like expensive computations. Okay. What did we need to do? We needed to go row-wise, even with that. So we do consume both streams and batch data. So but we just treat the batch data as streaming data as well. So the computations are row-wise. So it's sort of like you have a stack and you're pulling from one end and going. And then time becomes extremely important. So timestamps on all the data, when we receive them, when the event occurred, what is Kafka saying as the timestamp of the event, et cetera, et cetera. Yeah, we have to retrieve state, we have to be able to synchronize data from different sources as they come in based on their event time. I'm covering a lot here, and we can certainly pause for questions or chat about stuff later. And then it's best to have some observability into the data because we're proposing this lake architecture. So a little bit more about state. Having state basically is useful in addition to, like, we want to do some sort of aggregate or uniqueness check across, sleuth of records. But on top of that, it allows us to know, given what I know now, what was the state of some entity in the data at some earlier time. So as time progresses, you might have data come in that was supposed to arrive earlier, but it's late arriving data. It actually came later. So you want to be able to incorporate all of that most recent information to answer questions about something, even at an earlier time. So it's a way of keeping things sort of fresh and fluid and then moving. So this I basically covered. We have a stateful streaming engine, and Blob Storage is what's underneath powering the lake, and we consume from these sources and maybe a couple more now, and we can basically write to wherever. That's Upsolver. So that's a technical, not a pitch, but technical sort of what we do. So in your reference architecture, for example, we would live there. So, we could live in a lot of different places because, as I explained, it's a platform that can do a lot of things. But right now we're telling the story of ingesting high quality data into Snowflake. So there it is. I'm going to skip this slide, but basically we guarantee strong ordering and exactly once processing of all data that comes into Upsolver and is written somewhere. Any schema changes, we adapt to automatically, and we notify you of schema evolution. You have like deeply nested fields, it'll be flattened automatically, so on and so forth. Okay, so the summary of this presentation is metadata, state store, row-wise operations with a data lake that allows you to synchronize pipelines, gives you near real-time data products. Now, sorry.
One question.
Yep.
So you're talking about state. Is the state something that your system is constantly updating, or is it more like a runtime evaluation of when I'm asking the question to the lake? Like I have to provide the time as well to get this is my time slice. I'm like paying attention to when I'm asking the question becomes important.
When you're asking the question isn't important, but when you're asking the question about is important. So you do provide like the event time window, right? You say between 10:50 and 10:51 this morning. I want to look at those events that were generated at that time, not arrived. So it could have arrived at 2 p.m., right? But based on that window, I want some answers. But yeah, the other cool thing is we store the state as and like also in S3 buckets. So it's like it's really easily accessible and like queryable and stuff. Okay, I'll do a quick look at what Upsolver looks like, and then I said promised Python, so show a little bit of Python. But yeah, we are a SQL-only tool as far as the UI and the APIs are concerned. We just built a Python SDK on top of it, so that you can use it with your Python workflows. Okay, so I'm not going to actually run through like run commands, but everything is essentially SQL statements. So there's credentials here, but that's fine. So basically, we just create a Kafka connection and with the configuration properties in a SQL statement, and then what we do is this is readable, legible. Let me make it a little bit bigger.
Can you get larger, please?
Sure. Thanks. I don't know how to scroll, but maybe I don't need to. Okay. So yeah, once I create the Kafka connection, right, then what I'm doing here is I'm saying create this table. It's empty right now, but it's partitioned by the events date of the queue of events coming in. Then I create a streaming job, so that's the keyword sync job, which then reads directly from the queue and populates this table over here. I'm telling it what the payload's gonna be like. I mean, just that it's JSON. I don't have to tell it the schema or anything. That's gonna be auto-inferred. And yeah, so topic to consume and where to write it. That's it. And now immediately I can query from this table. So if I run this one, that table is coming in, and I'll get a query. What is this? Oh, okay. Okay. Yeah. So this is the last. It's showing the last 10 events that came in directly from Kafka. And then what I want to do, let's say I want to do some aggregations. Oh, by the way, so the query is, we're using Athena to run the query. So it's AWS only stack. So the data is being loaded into this Kafka data raw table in S3. It's already appearing on the left here as thanks to AWS Glue catalog. So this is the database, and this is the specific table that we just pulled in. You also get information on the data as it comes in, which is why the observability thing. But and then Athena is used to execute any queries that we want to run from Upsolver. Okay, so now I want to do some aggregations. Again, create table. I'm creating this aggregate table of this since it's populated, so you can see the volume of events that came in per unit time. This I can make it bigger and make it a little bit more sensible. But you get like, what is the density? How often was this field null? When was the first time it was seen? When was the last time it was seen? So you can see if like some important field stops flowing, then you'll be able to catch it from here. Whether or not it's a primary key, that sort of stuff. So that's useful. So building this aggregate, or creating this aggregate table, getting ready to write to it, and then this is where I'm actually defining that aggregates. Notice again the sync keyword. So basically, this is telling me that this is a streaming process that should be synced up to this 1 minute run interval. And I am specifying that event time window as, in this case, the start time and end time of this run.
Is this a SQL dialect? My SQL is not strong. Is this a SQL dialect, or is this all standard SQL keywords and stuff?
It's like that.
Okay, that's all right. Because there are things in here like, I've never seen that before. But it could just be my lack of knowledge.
No, it's not like too much, but there, like the create connection and things like that. Okay, so now I want to, again, I can run this and see the data in this aggregated table. And if I run it now versus if I run it 5 minutes from now, the data are going to be different because aggregates are going to include the latest data. Why did this one? Cool. And then in this demo, we're also writing to Snowflake this table. So again, credentials. Okay, so you have to go into Snowflake and actually create a table. So we did that here. And then using the Snowflake connection, then we want to write, again, this as a sync job, we're going to insert into Snowflake table. So that's it. So now I have data coming in from a Kafka topic that I'm staging in SQLite and then doing some transformations and aggregations and then writing it into Snowflake. And the aggregations that I did basically, so I don't know if you were paying attention to what the raw data looked like, but it was a JSON with a lot of nesting about like who bought it and what items. So this is e-commerce, right? Folks are buying folks online. And in this aggregation, I have, well, what type of item was bought, subcategory, and then the name of the item, the price of each item, how many of that item was ordered, and then total revenue. I think it's another, so item revenue generated from sales of that item across some time window. So cool, I write that into Snowflake, and now I can query it in Snowflake as well. That's my workflow. And then we come to Hex, which I've been playing around a lot with recently, and it's actually pretty cool. How do I make this bigger though? Okay. So it's a notebook service. So this notebook is, in Hex's cloud, and it's just similar to the Jupyter notebook experience, which I really appreciate. So, okay, so we built this SDK that I mentioned. So we just install and import the Upsolver SDK, Python, interesting naming, and then bring it in as Upsolver, bring in our favorite packages like pandas for data scientists. And then I made a connection. It's with an API token from Upsolver, which this time I've hidden it. And once I have the connection, then I can run queries in Upsolver from here in a sort of Python-ish feeling environment, right? So it's just SQL wrapped into a string, and then I am asking pandas to interpret that SQL, use that connection, and run it. And here it is, nicely. So this is, again, the raw data. So this is a little bit easier to look at than the table format we had before. So yeah, we've got the data is coming in as items and then their category and so on and so forth, shipping info, et cetera, Pretty, I mean, not super messy, but kind of like a lot. So it's nice that Upsolver does figure out what the schema is. Here I am selecting, and then the other thing is we have this information schema for each table, for all the data assets in Upsolver. So you can get like metadata level information on them. So here I'm looking at in the raw data table, I'm looking at all the different columns that are in there and their attributes. So customer address, for example, is it a primary key? Again, first name, last name. Has it evolved? Has the type evolved? And here's one where the type did evolve. So what is this? Unit price. So it used to be a double. I don't know. It's going to be. I can look at the whole thing, but basically what this tells you is it used to be a double, and then it changed into something else. And Upsolver is telling me about that.
Can I quick ask?
Mm-hmm. Yep.
So that means that it's making these inferences about the data that's coming in. It's not, you've never actually told it it's a
Exactly.
double.
Yeah.
And then it's later saying like, oh, I was wrong. It's not a double. It's
No,
a double.
it's not that it was wrong. It's that the payload changed.
Okay.
It was a double, and then at some point the Kafka sent me something in a different format. We can take a look at what specifically that's changed to. And then if it changes back, then I'll get another entry in this type conversion or whatever it's called, type evolution column. So I can, as an engineer, I can go back and see when that happened, And maybe if I want to figure out why it happened, I can, or at least I can do a casting for the relevant period of time to get the data back into the format that I want. Yeah, auto schema evolution is pretty cool. We're definitely not unique in doing it. AWS Glue does it. Databricks Delta Live Tables is pretty good too, but it's I think it's really cool. Yeah, and that's really it. Just looking at the data in a couple of different ways. Oh, and then this is more a hex feature than anything else, but I thought this was really cool that you can actually make, you can use Snowpark. So have you guys played with Snowpark at all? So it's basically a Snowflake's Python SDK, I guess. So it helps you incorporate Snowflake data and the Snowflake computation engine into data ML pipelines. So you can make a connection from your Jupyter Notebook to Snowflake, and then you run Python or Pandas transformations, and it just gets executed in Snowflake instead. That's pretty cool. So yeah, you can make this connection from Hex and then just use Snowflake as engine in a cell. So like the seamlessness is what I like about it. But yeah, now I'm querying from the Snowflake table rather than the Upsolver table of the same thing and getting these results. And also it like gives you one click. This is also cool. Again, more a Hex thing than anything. But if you instead of Python or SQL, there's a visualizations tab, yeah, and then you can choose like I want a chart, and then you can say what data frames. I have all of these data frames that I've worked with in this notebook that are accessible, right? So let's say raw is probably not a good idea. Also get stats. This is the information schema table. We pulled in. Is it going to automatically? Let's see if there's anything to really see here. Oh, sorry. I want to do, these are just columns. Sorry, this is not going to work. This is not a good example to choose because columns are not going to have interdependencies. Let's look at the aggregate orders again. And then it's generating this like value count or sum of order count for me out of the box. So I thought that was pretty cool. So yeah, I don't know how relevant all of that was, but I like that. So I started coding in C++, and then I coded mostly in Python, and now I'm helping build the SQL-only tool. And it's really important to me to have a Python SDK to have some way to reach the folks like me who are much more comfortable. And I mean, there's a lot more that you can do in Python. I mean, some people will tell you can do everything in SQL, but that's not quite true. So being able to incorporate the Upsolver engine and the SQL into a Python workflow is really cool to me. So I wanted to show that off. Yeah, that's it.
Cool. Thanks so much.
Thank you.
Any questions from y'all?
I have a question. I think you mentioned earlier that Upsolver guarantees exactly once processing. I don't know if this is like Upsolver secret sauce, but can you talk more about that?
It is kind of secret sauce, but I mean, we want to talk about it insofar as it's good and important, and it's something that I think folks really want. So basically, because I'm just going to talk about it a little bit generally. Most of our data are transferred in a distributed system, right? Like distributed systems talk to each other and data gets transferred. And what happens is sometimes you want to be on the safe side. This is one of the reasons for which we have more than one record of the same data. But you want to be on the safe side, so you guarantee that you're sending the message at least once. But you're not guaranteeing that it's going to come exactly once. So you might emit the same message like 2 times, 3 times, or a system goes down, and then like the AWS outage yesterday, and it comes back on later, and it's like sending stuff that was missed, but it like overcompensates or something like that. So there are many reasons for which the same data record, like John bought a backpack at this time, gets emitted and arrives in my database or in my analytics database more than once. So I want to know when that happens, and I want to be able to use that a record only once, analyze that record only once, exactly once, because otherwise when I go and do aggregates or analytics, then it's gonna pollute that, right? It's gonna say, I'm gonna think that I sold 2 backpacks when I actually sold 1. And this is extremely, a much more like impactful example is like in finance, where you do a transaction, you want your credit card to be charged once, not twice. 0 is fine, but at least you don't want it to be more than once. So exactly once becomes really important, especially for streaming processes, and it's something that it's hard to guarantee because of state. So there's this trade-off between how much you want to keep in memory and how fast you want the throughput to be for any streaming service. So even like Kafka and stuff don't guarantee exactly once processing. So Upsolver does. So what we do is, and part of the secret sauce is that there are these event time-based windows within which the executions are going to happen, right? But within that window, we will guarantee that all the events that we push through are strongly ordered, and each, if the primary key is going to help us determine, help us make sure that exactly once will you get an event.
So you said you didn't want to let go of Python, right? What sort of things were you doing in Python that you didn't want to let it go?
I mean, I've always really worked with data. I did a little bit of front-end stuff with like fast API and stuff, again, like very Pythonic. So most of my Python experience is in the context of data and ML pipelines. But I love it because of how easy it is, right? I mean, not that Python is always easy or that you can't do complex stuff with it, but it's that like, I don't bang my head against the desk quite as often as I did with seg faults in C++. And things are not quite as particular as like SQL needs to be, right? So was that?
Well, I'm just kind of wondering what sort of maybe operations, just an example of operations that you're doing on the data that you're working with that you find easier in Python versus doing it through a SQL-based interface.
Yeah, so I was doing NLP as a production service, right? And in that pipeline, there's like all the packages that I needed to make so you're asking, a person asks a question, let's say on the Airbnb website, about their booking, right? Taking that utterance and turning it into a vector representation, a numerical representation, and then transforming that, normalizing it, et cetera, all the things that I needed to do, and then using a large language model like BERT to do stuff with it. I mean, in this case, that's the vectorization, and then some other transfer. All of these things are available in Python in a way it's definitely not available in SQL. Now, probably Scala or R, you could do maybe a lot of the same things, but by and far, like the folks that are writing these packages, they're writing for Python engineers, and it's just easy to work in that stack.
I have a question for you on the batch versus streaming stuff. So context for me, anyway, is that my team is currently dealing with a lot of batch. We do a lot of nightly batch, tons of processing on healthcare claims data, and are desiring to move to more streaming architecture. From your company and where you've seen, is that transition something you see within your own customers? And then is there anything that you've observed about how they navigate that transition? So you've seen customers doing that kind of thing. Because that's a real problem that we have to solve. Just curious on your thoughts.
Yeah. No, I mean, the success stories that we have with some of our, especially like large corporations, like for example, I can talk openly about this. So are you aware of Centene?
No.
Okay, yeah. this large healthcare company also, Centene, does like Medicare, Medicaid across the country. They were doing their, they were incorporating, so if all of the records sort of get updated when they do, right? Throughout the day at pharmacies and at various, healthcare facilities, folks are entering records. So that's the sense in which it's streaming. And they're also doing like sort of batch stuff. But when they moved on to Upsolver, like things became a lot more seamless. Like if their entire ETL team onboarded with us, 50 plus engineers onboarded with us in like a couple months, and like hundreds of pipelines. It's the ease of things that they would have to put, or any of our clients would have to put guardrails around, such as like exactly one's processing, or various, like when you're doing transformation, like later writing data, for instance, like you'd have to do a look back period and say, oh, look back in the last 24 hours or whatever to see if something new has come up, and so on and so forth. Those things are abstracted from the user and just like a keyword or something. So it becomes a lot easier to just write the same pipelines, because that sort of cognitive load is gone. But you would have to change your tooling, right? So
Yeah.
whatever. So Centene, for example, they were using AWS Glue and PySpark scripts, and they replaced all of that with Upsolver. So that's the trade-off is, and then sometimes hard to convince, if you're doing things a certain way. But it's we would replace all of that. Like any what do you use for your batch pipelines?
Airflow.
Yeah.
Yeah.
We could definitely replace Airflow, and it would be. Have you used the dataset triggering yet in Airflow?
I am not on those teams, so
Right.
that's a little bit beyond. I know Airflow. I know
Yeah.
we use Parquet files and Athena, and like there's a bunch of things that, like boom, boom, boom. Like I recognize a lot of those things you set up there, but the actual like mechanisms are beyond me.
Airflow is completely agnostic to any of the data that is actually passing through, right? And so when things fail, it's sometimes hard to see because the Airflow run might have said, so you might have all green in those little boxes, but the underlying thing is crap. So that sort of thing, it's easier to catch when it's data driven. But yeah, I was going to talk about the data set based triggering. So we built something while I was an astronomer. We added data set based triggering. So as opposed to saying every day at 12 a.m. run this pipeline that does this, we instead said, okay, when this data set arrives in the S3, when this file arrives in this S3 bucket, then we run this pipeline using that data. So it's a little bit more using the data to trigger, but it's still like it's just a string. So if it finds that from that like S3 protocol or whatever, if it finds that string, then it will start the pipeline. It doesn't actually check to verify that that's an actual data set. But anyways, so in this case, you'd be able to get rid of Airflow. Instead, in Upsolver, you'd say, you create the same connections, and then just say what transformations you want. You wouldn't have to say when to run them. That's going to be determined by the logic in your SQL.
Have you found that these teams that have done that have done a big bang transition from system A to system B, or is it somewhere in between? Like they've got a bunch of stuff still over in the older system, and they're finding ways to phase in the new system and like work in a mixed world?
Yeah, no, that's a great question. So I'm most familiar with this Centene story, and I can tell you that it was kind of a fast turnaround, fast results. The head of that team is very happy with us. So they were able to, and this was a platform enablement team. So they were helping others write the ETL pipelines that they needed. But they had to put they had to do a lot of education around how to use this previous platform. Like, it wasn't even a platform, it was a combination of a few different things, right? So train folks in Glue, train folks in PySpark, et cetera, which was a lot of overhead. So for them, this, smaller team of the folks who were actually enabling this and setting the best practice around them, it was easy for them to move from that to this new platform, and now that training aspect is it's basically gone because folks can write SQL and have self-serve pipelines. So for them, it was really fast. But it obviously going to depend on your use case and workflow.
So I'm curious about the ingestion. So is the Upsolver something that people would connect to send data? Is Upsolver something that makes connections upstream to get the streams? Does it do both?
Yeah, both. Either way.
Either way it goes.
Yeah. The connection is not the hard part. Sure, fair.
All right.
Yeah, you would. The more likely thing is you would make the connection in Upsolver.
Should I think of Upsolver as having a certain buffer that it works with as it's moving things to the ultimate destination, which I guess is the data lake?
So Upsolver has a data lake.
Okay.
So it's called SQL Lake, and that's where all the data are going to be staged. If you want, we do offer a version of it where you don't get the queryable lake. We still store it in S3 buckets, but not as Parquet, just as Avro. But details aside, that's when you get the more, you ingest from Kafka, write to Snowflake, as an example, and you're interacting with the data solely in Snowflake. You're just configuring the ingestion job in Upsolver. But yeah, the traditional way is you would bring it into SQL Lake, stage it there, be able to do transformations and queries in there as well.
Can you, I think we have an audience that has mixed experience with data stuff, and can you comment on a data lake versus a data warehouse?
Sure.
Help us understand that a little bit.
Yeah, to the best of my ability. So databases have, maybe I'm not the best. Maybe one of you guys should answer that.
I asked the question
I was probably the one who used the terms incorrectly. Data lake versus data warehouse go.
Because data, you said Snowflake is a data warehouse, is that right? I'm trying to map some of these things out myself in my own head.
That's totally fair. So the most common data warehouses are relational data warehouses, right? So such as Snowflake, where you have these tables and you look at those tables. When I say tabular, there are columns and there are rows in which data are stored, and it's the same way that you interact with data is the same way that it's stored. In a lake format, it's a little bit further away, so you don't have, the data are stored in a more compact and optimized way, and the way that you query the data, get to the data, is through a metadata layer, which, for example, can be a Hive meta store. So you have this mapping of what the relationships are between the files and entities, and then when the query happens, you go through that metadata layer and then basically get to the node that's relevant. So yeah, data lakes are much more efficient space-wise than data warehouses. Computation is also a lot cheaper.
Are they optimized for exploratory stuff? Is that a just helpful distinction? I don't really know.
I would say that you can do exploration in either. I think if you have a pipeline that's regularly doing the same sort of transformations, then it's much cheaper to do it in the lake than in the warehouse. Basically you're paying the warehouse for no reason because it's sort of the same formula over and over again.
Would you mind going back to the slide that you showed about the middle of the presentation of the, I'm trying to think of how to describe it. I think
Before or after?
Is that a dark slide or a light slide?
Well, yeah.
It was explaining the, I think it's number 12 perhaps, or, oh man, I'm blanking. I think at, yeah, 14. I'm now that I've seen the visual of the code you were writing, I think I might be able to understand this a little bit better. I just wanted to kind of have this up while we're talking so I can slowly start to digest it.
Yeah, because the state is written into the lake, if you lose a connection and you spin it back up, it's still all there. You don't lose anything.
So when you had Hex, I'm not super familiar with Hex, was it connected to the unified platform, or was it connected to what you have listed as targets over there as lake query engine?
It was
Oh,
connected.
good. Talk about Hex, because I had no idea what that was, but I thought every Python person probably knew.
I mean, it sounds like it's a Jupyter, like a hosted Jupyter thing, sort of, but more. I don't.
Yeah, that is a good description.
Okay. And that's an assumption that people know what Jupyter. Do folks know what Jupyter is?
I have no idea what Jupyter is.
Okay.
I don't
So-
mind admitting ignorance, so yeah.
No.
Jupyter notebooks are a tool commonly used in data science to be like, here's the sequence of computation that I want to do. I'm going to bring in my SQL tables, I'm going to bring in all sorts of data, and then I want to crunch some numbers on it. I want to run it through some algorithms and do some processing and get some visualizations at the end of like, I'm looking for a graph to see are there patterns in the data, whatever your problem might be. It's kind of and the reason why it's called notebooks is it's sort of modeled after that old, lab notebooks that some of you might have done if you were in more of a science or engineering kind of degree. So that's my best approximation of what a Jupyter notebook is. And so then there's like hosted versions, and so Hex does stuff like Jupyter notebooks, but more, I guess.
Yeah, so let me do one at a time. So Hex was connected to both Upsolver and Snowflake in that notebook. The Snowflake connection wasn't as important. I just thought it was cool to be able to pull it in. But the main thing was, the main thing was that I got the API token from Upsolver, put it in, created a connection within the notebook in Hex, and now I had access to my data lake. Right? That's how connections work, but just being able to query from the notebook is what the Python SDK allowed. So this is a notebook. What I have open right now is a Hex notebook. Not entirely sure where the name comes from, but the way that I think of the defining characteristic of a notebook is that there are cells where you put individual units of code and then you can execute them and you can get the output right away. So, in Python, like we want to import different packages, right? And then I run this and that's done. So instead of a Python script where everything's in one place, this is like more modular. I don't know that I'll be able to do anything too complex on the spot, but so if I want to do a function, right? I don't know.
Print hello world.
Print hello. Okay, sure. So I read a Python function, right? A bad one. Actually, I'll print not return. Okay, so I put that in one cell, and now it's a function that I know, and I can access it, call it here now, right? And it executes, and I get the output over here. So I think this is why data scientists love notebooks so much, is because the output is there right away. So you can imagine pulling in a big CSV file, and then you pull it into a pandas data frame, and you do data frame.head, and it gives you the first 5 rows. You do .hist, and it gives you a histogram of whatever the data is in that, and it's all inline. So
It's good for telling stories too. So it kind of weaves in the ability to add documentation. When I think of a Python script, it's like I don't care about the guts of what's in there. But sometimes with a notebook kind of thing, you actually do you want to see the code that's with it, you want to understand the chunk that goes along.
It's almost like a blog post.
Yeah, like
That
a
also-
interactive blog
Yeah.
post, sort of. Yeah, pretty powerful.
I haven't played around with this too much, but you can publish a hex notebook as an app, which is what this is supposed to be. Again, I haven't played around with it, but I think once you publish it like this, like you can, if I had like bouquet plots or something, you'd be able to interact with the plot from here, from this app.
So I have one question, like going back to the Upsolver part. I don't have any knowledge in this domain, so I'm trying to picture what's happening. So it seems like Upsolver is a product or is it a service? I mean, in the sense that you talked about Upsolver as being something like a data lake, I assume. So it looks like you get data through Kafka or whatever the ingesting model is, and also some kind of batch data. And it comes into the data lake, the Upsolver data lake, and seems like you do some kind of transformation of the data based on whatever the logic is. And then you feed it back to other consumers like Snowflake and all this. So the advantage of using Upsolver is that it's a better data transformer, or what is the advantage of using Upsolver?
Yeah, it's a better grid data transformer that can handle both streaming and batch data, which is pretty unique, especially for, it's hard to do joins between two streams, and we solved that.
Can you go to a code example where you're doing a transform here?
Sure. Let me quickly finish the thought
Sure.
here. So we have our own engine. It's Spark-like, I would say, but it's not Spark. And storage and computation, everything is super optimized. So it's cheaper compared to like a Databricks or something. You bring your own VPC, you bring your own cloud, so the data never leaves your cloud, right? It stays there. It's just a service, and that's it. We do have a fully hosted option as well, but
So like for a company like Mac, after where Mac works, how would they use Upsolver in the sense that they have already in-house data, and then they would use some way to send the existing data to Upsolver, and also use Kafka or something to feed the streaming data. Is that how it works?
yeah, I mean, it depends on when you say in-house data, right? It's let's say there's a end user face. Actually, you should there's maybe an end user facing application, right? That has its own application database. Let's say it's Postgres. You then in order to do any analytics or in order to use that data for anything other than just powering that application, right? You want to pull it out because you don't want to mess with your application DB too much. How are you doing that? So I don't know, what message bus do you use?
We use Kafka.
Kafka, okay. So it's being written out by Kafka, and then there's a Kafka consumer.
Yeah, we publish events to Kafka related to application state changes and stuff.
Yeah, and then we pull that into where?
Then it goes, I think from there, we might be writing directly to Parquet, where I'm at the limits of okay, what do I actually know? So somehow the events get published to Kafka, and then I think there's a process of it's writing them direct to S3 in a Parquet format. I don't really know what that means, but I've heard that term.
Yeah.
And from there, that's where our data platform starts to take over. We've written it to this place in S3. We can start to ingest it. I would assume that Upsolver would kind of come in at the same spot.
Yeah. Yeah, we would replace the Kafka consumer, and we would still leverage S3 and do a data lake, but you wouldn't have to do the Parquet compaction yourself. So a team has set this up, and probably a team has to maintain it because it's complex logic, right? But with Upsolver, you wouldn't have to worry about the what's under the hood as much. You just say, okay, this is my Kafka source. This data comes in. This is my SLA that I want the freshness to be at, and it's just kind of happening.
This example you've got right here, it's probably oversimplifying. It's looking at the last minute of Kafka events, and it's adding them to a materialized view of sorts that you can then query later and get the most up-to-date version of that.
Yeah, this is actually writing to a table, this table that we created here. Yeah, you're right in that, like, within the run interval, right? Yeah, let me just make sure what I'm saying is correct. Yeah, this aggregation happens within each run interval, and then that's upserted into the larger table that's here.
And I heard you at the very beginning talk about materialized views. Is that a choice for a type, or is that just what you're doing behind the scenes to make this possible?
Both. Yeah. So the way that we enable, and this is true across other places too that offer the same thing or similar thing, is when you do joins between when you basically the sync keyword, right, is what tells you that you want the processes to be synced with each other. So each individual, if you're in the Airflow world, right, it would be tasks that are dependent on tasks or jobs that are synchronized. So, and it's on an event time window. So you're not gonna do the syncing based on the clock time. You're gonna do the syncing based on when the event was generated. So I have one Kafka queue that's giving me patient details, and another Kafka queue that's giving me provider details, right? They're separate, coming from separate services. And then I do the syncing within Upsolver. I'm not gonna do it, at like 8:30 p.m. Like that I'm gonna do it at 8:30 p.m., but that has no bearing on what actually gets joined together. The only thing that has bearing on what gets joined together is when that data was generated, sent from those two queues. So you might have more pile up in your patient queue, that's fine, but I'm going to do the relevant matching. This is one of our biggest client base is ad attribution, advertising, where like you show someone an ad and then they click on it, but they might click on it immediately, or they might click on it like 5 minutes later, but it's still the same ad that you need to attribute to. So there are two separate streams that you have to like make that relationship between, and that like causal relationship is made possible by this event time.
So there's just a random question, is like clock skew, so like a not my problem kind of thing. Like you guys have to figure out how to synchronize your clocks. Like,
yeah, at some level we have to trust something upstream.
Okay.
So yeah, if it has to come from upstream. But what we do is we do also every event gets Upsolver event timestamp. So you could say regardless of what's happening upstream from here on, do things synchronized.
Okay.
So you can do sync pipelines like that. And then the other thing where materialized views comes in, right? So you have a pipeline where things are dependent on each other, and then that's supplying a data product. But in the meantime, if you want to answer questions from that pipeline, the way you do that is you do materialized views into the relevant assets that you want, right? This view doesn't have, like, it's not going anywhere else. It's just for someone who has a question, right? It just wants the snapshot in the pipeline of that data right now.
So do you have packages that you've already developed for things that are very common? For example, we're looking at AWS security and how do we analyze security events within AWS, Amazon Web Services. So we could try to capture all the different data streams and logs and Splunk logs and cloud trails and all that good stuff, and develop our own process. But it seems to me that a lot of people are asking the exact same question. So do you already have packages that grab like all the information from different sources in AWS and kind of come back and say, okay, you've got a security event going on over here. or when we go back to look for the cause of a failure, you know, we can go in and just say, you know, here's the server, here's the application, tell me what happened, you know, tell me what the timeline was or something.
We don't, because I think we'd have to cover a lot of different use cases, and that's not what we're focused on right now. But I can say it would be relatively easy to write that just because of the synchronization aspect. Like once you pull in data from all of those different sources, you're not going to have to repeat like the logic, right? All the data now live within Upsolver in their latest form, so you can do the pipelines and attribution from there. What we do have is not the same thing, but we do have templates for various kinds of workflows, like you know, Kafka to Snowflake is just an example, right? You've got Kinesis to Redshift, or you know, like various flows that people usually do. We have we have about 100, I think, templates to get started with, and you're very likely to find your not your necessarily your use case, but your tech stack is likely to be in there.
My guess is that there are vendors out there that would be happy to sell you their opinionated take on the data. I mean, my company consumes tons of healthcare claims data that powers a lot of the way we do data science and machine learning and all that sort of stuff. We pay for these fees, basically. So there are there's whole industries out there based on like, we got a data set, we're happy to let you have at it for a cost, of course, depending on what you're doing.
You mentioned runs in RVPC. What's actually running there? How does that get installed there? What's the pricing? Not that you would say exactly how much it costs, but is it a pay per query or pay per stored table?
I think we've very recently updated our pricing model, so don't hold me to this, but the last that I knew, it was $99 per terabyte of data ingested. Transformations are free, which is to say, like within the lake, any transformations you do, that's on us, but like it's per data ingested. And seats, unlimited, like seats are not limited or queries are not limited. So that's pricing. So for Upsolver deployment, we need an S3 bucket, we need a glue catalog, and we need a Athena. Those are the three things.
Not even like other EC2 instances?
Oh, sorry, yes. We use spot instances for the compute. You're absolutely right. Those are the things. So if you are an AWS user and you just want to, you know, provision a little bit of space for Upsolver, that's like the easiest way to do it. Yeah, or you can say, you can go for the fully hosted version as well.
Last question, I promise. Do you have any customers that have implemented Upsolver in Kubernetes workloads?
I have to get back to you on that.
I will give you a card.
Okay, sounds good. Yeah.
How do you use it like that? You asked that question. How is it coming into play like that?
Well, so we have an ingest pipeline. So we have a bunch of customers that have different clusters deployed for customers, and in their environments we put a bunch of sensors. Those sensors are collecting a bunch of data and summarizing it, and then they're sending this massive amount of data to our individual clusters that are all writing to Kafka. And so we have a service that we wrote that falls over all the time and that does ingest from those sensors to Kafka. So I see one potential location for Upsolver. And then once it gets into Kafka, we have another service that takes it out of Kafka and puts it to S3. So I see another location that Upsolver can fix there. And then because I'm the infrastructure nerd, literally that graph there of written rows over time, I see as a mechanism. And then you showed the actual events that had 100% density versus strings and all that. I see that as a tool for my team to know that we're actually getting the data that we want from a customer.
Okay, so forgive me, Ronnie, so are you thinking you're running multiple instances of Upsolver? Is that what I'm hearing here?
Only because of the way that our software is implemented, we have an individual cluster per customer.
Right.
I would see Upsolver being in each of those clusters for us.
Okay.
Like
Replacing
an
those-
appliance you can put in to the cluster for, on behalf of the customer.
And
Yeah.
is that the way it would work?
It could work that way, because, I mean, in this case, it would be, yeah, you'd be the intermediary and would have to be deployed in each of those, your customers, yeah.
Okay,
I don't know why it wouldn't work.
thanks. So I'm just getting a little better understanding of architecture and where the pieces are living. This is exciting.
I don't get to
Well, I mean,
use
I think it is because it's kind of like you've got your particle collisions here and your astronomy data here, maybe credit card transactions here, and then security logs. Right?
We found out that in some cases we move more data than Netflix sometimes.
Okay. All right, so then maybe we'll bump it above credit card.
That's a lot of data.
That's very cool.
It's because it's the ones and zeros going from this thing to this thing. I mean,
I mean, if you're going to keep track of it all, it's
luckily there's a thing called NetFlow that summarizes that, but even
so.
even that, like summarization of network data,
Yeah,
it's
great.
billions of records a second.
Huge volume.
It's insane.
Well, do we have any other questions for our speaker today?
You can connect with me on LinkedIn if you would like. Thank you so much.
I'd love to know any Kubernetes implementation.
Okay, yeah, I'll follow.
Well, thank you so much for presenting for us.
Sure.